So in the previous segment, we have spent quite a lot of time looking at the self-reporting technique. And now we will switch to a number of other techniques. We'll do two of them rather quickly because they're very simple, but nevertheless very effective. So the first one we do is 20 questions. So 20 questions is actually named after a game that you may have played as a child. So one person keeps something in mind, like a dish or an object or an animal, and the other persons have to ask questions to guess what the other person has in mind, right? And they can only be yes or no questions. With an interesting twist in this game, it is not the expert who's going to keep something in mind, and then we as knowledge engineers have to ask questions to the experts. We're going to invert the game. So it is the knowledge engineer that will think of some object in the domain. So clearly this requires that you are a little bit familiar with the terminology and with objects and relations and what's important. But you think of something that is important in the domain, and then you challenge the domain expert to guess what you are thinking of by asking a series of yes-no questions. And you keep track of the questions that they ask. So the point of this is of course not whether the expert can guess what you have in mind and how many questions they take to do it. But the point is that the questions that they formulate will reveal interesting aspects of the domain. So in class we often play this game, and I think in the Q&A session we will also play this game live. So think of say a meal, right? So the knowledge engineer is thinking of a meal, and now the expert is going to ask questions. Is it a hot meal or a cold meal? Does it have meat or does it not have meat? Is it a Dutch meal or is it foreign cuisine? Is it for breakfast, lunch or dinner? And the knowledge engineer answers all these questions to keep the game going, but each of these questions is revealing something important about the domain of food. Namely, there's an important distinction between hot food and cold food. And there's an important distinction between national cuisine and international cuisine. So the main purpose of this exercise is of course not to guess what you're thinking of, but it is to determine important properties of the domain by keeping track of the questions that the knowledge engineer asks. And our experience is that experts find this a rather entertaining thing to do. It's very lightweight, but it is surprisingly effective, certainly in the early stages of the knowledge acquisition process, to get a grip on what are important distinctions in the domain. So if you ask an expert explicitly what is important in the domain of cooking, they may not actually be able to verbalize themselves what is important in their domain. Experts are typically not very good at that. But if you cast it as this game and you put them in this game position where they have to, they're being challenged to guess what you're thinking of, then they will come up with all these questions that unwittingly reveal what is important in their domain. In a way, it is much more effective than explicitly asking them for these distinctions. So you might actually want to try this because it is surprisingly effective, and experts tend to like this form of knowledge acquisition because the cognitive load on them is much lower than the cognitive load would be if you ask them to list explicit distinctions. Okay, so that is one particular technique. A next one is a technique, or actually a family of techniques called laddering. I think it's a bit of an unfortunate name because we're really after organizing entities in a hierarchy. Okay, and with a bit of imagination, you could think of a hierarchy as having some kind of laddering structure. So that's how it got its name, and actually it's got its name from cognitive psychology. But a computer scientist would never call this laddering. The computer scientist would call this hierarchy formation. And it's important to realize that these hierarchies, they are found in almost any domain, but they have very different types. So we've already, when we did, remember when we did the UML diagrams, we saw different types of hierarchies. So we saw class hierarchies, where different types are nested into supertypes. We saw process hierarchies where one process was part of another process, or we saw different types of hierarchies. And I urged you make sure that you didn't mess up those hierarchies, that you didn't mix them, that you kept track of one kind of hierarchy or another. And also constructing these hierarchies is very useful to do with experts. And actually, as part of your homework for this week, we will ask you to do this exercise. So we're making hierarchies. Hierarchies can be of any type. And just as with the 20 questions, this is a technique that is very useful in the initial phases of the knowledge acquisition when you're trying to find the most dominant structures in the domain. And this can even be done by experts themselves if we give them the right tools without the help of a knowledge engineer. So probably in your small size projects you will probably do everything together with the expert, but in principle you could ask them to do this. So here's one example of a ladder, right? So what do we have here? We have a ladder, and let's see what's in the hierarchy, right? So we have, and this was actually from an example where we built an expert system together with students. We built an expert system for room allocation in a new office building. So a company or a department was moving into a new office building, and they had to allocate rooms to people. So what was important in that decision? So in the task of room allocation? Well, one thing that was important was the role that people played in the organization. Another, and these roles could be decomposed into, okay, we had office assistants, we had managers, we had researchers, and so on, right? So this was one particular aspect decomposed into a number of different aspects. Another thing that was important was whether people were smoking or not. Of course, the decomposition there was only in smokers and no smokers. Right. Other decompositions were decomposition in gender, of course, male and female. Decomposition in size, not size of people, but size of offices. So we had single offices and large offices. Locations, where we had central and non-central locations. Typically you wanted, say, office assistants in central locations and researchers in non-central locations. Right, so each of these were different aspects of different criteria, and each of these criteria was decomposed into sub-criteria. Right, so this was a rather abstract ladder of where you are decomposing a hierarchy of decision criteria. A completely different hierarchy is this one. So this would be familiar to the psychology students among you. So this is a part of hierarchy. This is a part of hierarchy of the brain. So roughly speaking, the brain consists of 3 areas: the bit at the front, the bit at the middle, and the bit at the back. And then each of those bits consists again of different parts. And each of those different parts again consists of different parts. Right? So the cerebral cortex, the bit of the brain that distinguishes us from most other mammals, it is part of some other part that is part of the forebrain that is part of the brain. Right? So notice that this is a completely different hierarchy. Right? So here we are making a hierarchy, a part of hierarchy, whereas the previous one was a much more abstract decision criteria hierarchy. But we are using the hierarchy mechanism in both cases. Here is a third one. So this one looks a little bit like the first one, where this was from a very simple example where you were diagnosing a car. Right? So this is often a toy example that we use in our illustrations. Actually, I think this was for choosing a car. So when you're choosing a car, you have to choose what car fuel you want to have. Right? So do you want to have a car that is fueled by unleaded fuel, by diesel fuel, or an electric car? And each of these choices again have different pros and cons. Right? So unleaded is very easy to find on the road. You have good mileage performance. Diesel is also common, but you have poor mileage performance, whereas a battery is very clean and quiet, but it's not so easy to find, and you have limited journey length. So this is again a logical decomposition. which is very different from the part of composition that we saw before. So we are very liberal in what kind of hierarchies you're making, but in general, making hierarchies turns out to be a very useful thing to do in early stages of knowledge acquisition. Here's yet another example. This is where we are splitting up a process. Again, a trivial example from daily life. We're taking the process of preparing breakfast, and preparing a breakfast, in this toy example, the process of constructing breakfast consists of 3 sub-processes. And each of those sub-processes, again, consists of a number of sub-processes. So this is a little bit more like the part of hierarchy, except now it's not a physical part of hierarchy, like in these brain parts, but it is a process part of hierarchy. But in each example, irrespective of how different they are in their nature, we are using the same tool, the same laddering tool.